Good evening, everyone. Today's podcast is brought to you by. Good evening, everyone. Today's broadcast is brought to you by. Where's the advertisement? What you mean we ain't got no advertisement? Prospects, NordVPN, Raid Shadow Legends. You have one job. I ain't trying to hear all that. Excuses or what? Get out, bro. Get out. Go. Go. Today's broadcast brought to you by nobody, but that's okay. Welcome to the show. Grab a snack, hold the baby oil, lock in, because today we are going to be talking about something that everybody thinks they know about, but they don't really understand what's going on the inside. We're talking about chlamydia, aka the burn, aka the clap. Yes, that chlamydia. But listen, this isn't about to be one of those embarrassing clinic conversations. We're not going to be getting all into the safe sex and things like that, even though everybody should be having safe sex. Make sure you guys being safe. Not really my business, but hey, do what you got to do. We talking science. So here's a little breakdown, right? Chlamydia sneaky. I'm talking your toxic ex calling you at 2 a.m. outside the dorm talking about some, hey, I just want to talk to you. She outside the new red talking about some, hey, I just want to talk to you. No, that is not how it works. Chlamydia does not stay outside like normal bacteria. Chlamydia packs its bags, packs a toothbrush, breaks into the cell like it's moving in, and starts decorating. It doesn't just enter, it moves in, and doesn't even pay rent. And the wildest part, your immune system can't even see it. It's like chlamydia is in your cell, with the lights off, hoodie on, sitting real quiet in the corner like, I ain't here. You don't see me. Don't even look at me. Meanwhile, it's building an entire little operation all up inside you. But before we get into the nitty gritty and everything, let me break this down step by step. Because if you understand this first segment so far, you're going to understand this entire infection. So, what exactly makes chlamydia different? Most bacteria stay outside of your cells. They be chilling on the surface, causing trouble, whatever. Little YNs, little ne'er-do-wells. Your immune system sees them and goes, bet, I'm gonna handle that. Chlamydia? Nah. This thing said, I don't fight fair. I don't throw hands. It goes inside the cell because it knows that once it enters, your immune system can't hang with it. It's like jumping into like a safe room, like you on card. No bullets can touch you, no grenades, no nothing. So imagine your cells are like, wait, who this? How you get up in here? Who let you in? But before the cell can even throw hands, chlamydia pulls off its first big trick. And that would be the infectious form, the EB. Chlamydia comes in like an undercover agent, like a secret spy. The elementary body, EB for short, acts like a tough little version that breaks into the cell, right? And once it's inside the cell, it should be digested by the cell. Keyword should. But chlamydia said, nah, bruh, I ain't going out like that. It blocks that process that would have killed it. And once it does that, it starts stage 2 of its evil plan, That moment, everything changed. So boom, the EB is inside the cell. Your cell wraps it in a membrane like it's trying to throw it away, right? But instead of letting that membrane carry it to destruction, chlamydia grabs the membrane up. It says, hey, bro, I live here now. You gotta get it. This membrane becomes the start of the inclusion vacuole, a custom bubble, a secret apartment. Basically, chlamydia's trap house inside your cell. And this bubble, this is the star of the entire podcast. This is the Beyonce of the infection. Everything revolves around it. Inside the vacuole, chlamydia will hide, it'll multiply, change forms, manipulate your proteins, dodge your immune system, and stay alive way longer than it should. Real toxic relationship. This bubble is like the Wi-Fi router for the bacteria. If it's on, the infection runs flawlessly. If it breaks, everything collapses. So y'all probably wondering, dang, why they didn't teach me this in school? Teachers don't tell you any of this in health class or sex ed because they're like, use protection, get tested, don't have sex. But we in college, we know what we gonna do. That's great. Where was the lecture about chlamydia building little secret rooms, little secret tunnels in my cells? Nowhere. But that's exactly why this podcast right here exists. That's exactly why this stuff here matters, because once you understand a vacuole, you understand the entire infection. So now that we know chlamydia breaks in, set up shop, it starts building this little Airbnb inside your cells. We're going to talk about what a vacuole even is, right? How it's supposed to work and how chlamydia flips it for its own survival. What even is a vacuole, bro? Well, I can tell you. So look, first time any of us heard the word vacuole, we was like, I don't know, fifth, sixth, seventh grade science class. Your teacher probably said something like, in plant cells, the central vacuole helps store water and nutrients. Meanwhile, you in the back of the class, daydreaming, thinking about, what am I gonna eat when I get home today? I wonder what cartoons are gonna be on by the time I get home. Not listening, not paying attention to anything, right? But here's the important part. A vacuole is a storage bubble. And basically, it's just a big old water balloon inside the plant cells, right? Plants use it to store water, keep shape, hold nutrients, and push out toxins. Gotta get all that bad stuff up out of you. It's like, how do I put it? It's like the plant's version of a pantry, a trash can, and a pressure support beam all at the same time. That would be quite neat if it was at a house, though. Now, here's a twist on that. Humans do not have a big central vacuole. We do have a little membrane components. We do have little membrane components, but we don't have that one big style balloon such as the plant vacuole. So when chlamydia sneaks its way like a little sneaky snake inside our cells and builds a vacuole, it does something the human body, the human cell, normally does not do on its own. So, all right, so now that we know chlamydia breaks in, sets up shop, and starts building this little Airbnb up inside your cell, we're gonna talk about what a vacuole even is, how it's supposed to work, and how chlamydia flips it for its own survival. Now, you probably wondering, what even is a vacuole, right? So look, first time we probably ever heard of the word vacuole was like sixth, seventh grade science class. Your teacher probably said something like, in plant cells, the central vacuole stores water and nutrients. Meanwhile, you in the back of the class wondering, I don't know what's for lunch today, you know? But here's the important part. A vacuole is a storage bubble. It's basically a big water balloon inside plant cells. Plants use it to store water, keep shape, hold nutrients, and push out toxins. It's like the plant's version of a pantry, trash can, and a pressure support beam all at the same time. Now, here's the twist. Humans don't have a big central vacuole. We do have little membrane components, but we don't have one big plant style balloon. So when chlamydia sneaks its way inside our cells and builds a vacuole, it's doing something the human cell normally doesn't do on its own. This is where the infection gets a little crazy. Once the chlamydia gets wrapped inside a membrane, it should be on its way out. But chlamydia hits the switch and redirects the whole GPS. Instead of dying, it takes the limazone and says, oh, this right here, I'm gonna turn this into my little luxury loft apartment. And boom, this is how the inclusion vacuole is born, the Beyonce we were talking about earlier. So this ain't no storage bubble like plant cells use. This is the Airbnb that chlamydia rents out with permission, which is illegal. It's renovating your cell, like knock down this wall, add some lipid shells, bring in googly furniture, steal energy from the mitochondria, and cut the immune system out the Wi-Fi. Your cell is basically the landlord watching all this happen like, wow, so you're really not leaving. And the vacuole is like the chlamydia safe house. Here's why this vacuole matters so much. Your immune system can't see through it. Think of the vacuole like a little underground bunker. The outside looks empty, regular, quiet, but inside there's an entire operation going on. Inside the vacuole, the chlamydia eats, it grows, divides, switches forms, sends signals, hides, manipulates, and prepares to spread. It basically becomes the CEO of your cells and fires all of the managers. Sounds like billionaires and millionaires of America. Why does the vacuole make chlamydia dangerous? Well, if chlamydia didn't have this vacuole, it wouldn't survive about 5 minutes in your body. Your immune system is just that powerful. It will fold it like laundry. This vacuole is its shell, its bunker, its HQ. It's like the bacteria is living on invincible mode inside a video game. And this is the reason why scientists care so much about it. If you can break this vacuole, you can break this infection. So now that we know what the vacuole is and why chlamydia needs it, the next question is, how does the vacuole actually protect the bacteria? Because trust me, that thing don't just sit there. It's working overtime. So we about to get a little real for a second, right? How does the vacuole protect chlamydia? By now we know chlamydia done broke up in the house, the cell, it's living up in there, but its own little room, own little party room in the basement, the inclusion vacuole, and it's living up in there eating up all the food, eating up all the hog moss like it's paid utilities. But now we got to talk about why the vacuole is such a big deal, right? 'Cause I'm not exaggerating when I say this bubble is the entire reason why chlamydia is one of the most successful STIs on earth. Let's get into it. First thing you need to understand is this. The inclusion vacuole is like the ultimate you can't see me shit. Your immune system, it has no clue what's going it has no clue what's going on inside that bubble. Imagine you're a security guard, right? And someone's robbing a house, but that house has blackout curtains, noise canceling walls, and a guard dog outside. You can walk past like, huh, looks normal up in there. That's exactly what your immune system is thinking. Chlamydia is inside the vacuole. The bacteria is literally hiding inside your cell, building stuff, multiplying, throwing a whole party. And your defense, your body, can't even detect it. It's terrible, but it's kind of brilliant when you think about it. The vacuole blocks the cell's defenses. And here's where things get a little bit crazy, right? Normally, when something bad enters the cell triggers alarms, right? From digestion, immune signaling, stress pathways, and apoptosis, which is the self-destruct mode, that red button. But the vacuole blocks all of that. Picture the vacuole standing there like a bouncer outside a party. Nah, bro, limestones, on the list. Step out. It won't let the cell touch chlamydia. It won't let the immune system detect chlamydia. It won't even let the cell break it down. This bubble is doing more protecting than the Secret Service. The vacuole lets chlamydia replicate safely. Here's the thing. Chlamydia cannot multiply outside the vacuole. It's too risky. Why would it dispose itself like that? Makes no sense. But inside the bubble, oh, it's on. Inside the vacuole, nutrients flow, harmful molecules stay out, the bacteria switches forms, they divide over and over and over and over again, right? The vacuole expands like a balloon. It's like chlamydia built the whole incubation lab inside the cell. And when the bacteria are done multiplying, oh my God, the vacuole either bursts the cell or releases new bacteria like a delivery drop-off. DoorDash, or for STIs. Chlamydia controls the cell's lifespan inside the vacuole. Now, this part right here is crazy, right? The vacuole doesn't just protect chlamydia. It's keeping the whole cell alive too. Why? Because chlamydia can't grow if the cell dies too early. So what does it do? It hijacks the plane called MCL1, the don't die yet protein, It stabilizes it on the vacuole. Your cell might want to self-destruct to stop the infestation, the infection. But chlamydia is basically holding the self-destruct button hostage. Like, try it. I dare you. The vacuole is the center of everything. This is why the inclusion vacuole is so important. If you remove it, the immune system detects chlamydia instantly. The lysosomes destroy it. The cell self-destructs. The bacteria cannot multiply, and the infection never spreads. The vacuole is not optional. It's a key structure that makes the infection possible. Think of it like the Wi-Fi router for the bacteria. No vacuole, no connection. No connection, no Wi-Fi. So, now that we understand how the vacuole protects chlamydia, next we're diving into the research paper itself. I'm breaking down what the scientists did, how they figured out the MCL1 connection, and what the results actually mean. So, this whole project is built around one primary research article. Chlamydia-containing vacuole serves as a platform to stabilize MCL1 and to interfere with the host defense. That title probably scared half the class, but not me. I read it with, 4 Red Bulls and, a couple Celsius and heart problems. But, things happen. Let me break down exactly what these scientists figured out. This section is important because it literally explains why chlamydia is so good at surviving. How does the host cell stay alive long enough for chlamydia to finish growing, Rod? Because, think about it. If the host cell dies too early, the bacteria die too. The infection is over. Chlamydia packed its bags and got up out of there. So, the bacteria needed a way to prevent the host cell from committing seppuku, or self-destruction, Most pathogens don't have a solution for that. Chlamydia does. And researchers discovered how. The answer was MCL1, the don't die yet protein. MCL1 is a survival protein your cells normally regulate very tightly when the cell senses stress, infection, DNA damage, or an immune attack. It breaks down MCL1, but without MCL1, the cell can activate apoptosis, which is the programmed self-destruct button that we've mentioned a few times before. But here's the plot twist. Chlamydia needs MCL1 to stay alive. So it hijacks the protein, holds it hostage. The researchers figured out that chlamydia grabs MCL1, pulls it towards the inclusion vacuole, and stops the cell from breaking it down. The bacteria said, me and that protein got plans. Y'all not touching it. How does chlamydia protect MCL1? This part is kind of crazy. Your cells tag older dangerous proteins with ubiquitin. Ubiquitin, which is kind of hard to say, are little flags that say destroy this. But the inclusion vacuole has enzymes that remove those tags. This process is called deubiquitination, which is a really hard word to say that I struggle with pronouncing, but I did it. So the vacuole becomes an entire workshop where chlamydia takes MCL1, cleans off the destroy me tags, and sends it back out like it's brand new. Chlamydia is basically running a protein repair shop inside your cell, but it's not being regulated by, taxes or anything like that. You should probably check on that. The experiments that the scientists did, they proved all this using immunofluorescence microscopy. They literally watched the MCL1 glowing around the vacuole like Christmas lights. Oh, Christmas. Santa, I want a Hellcat. Western blotting, they measured how much MCL1 was presented during infection. And inhibitor treatments, when they blocked the ubiquitination, that is so hard, it's like a Zulu nation, MCL1 disappeared. The whole cell started dying. The bacteria couldn't grow. Seemed like all hope was lost. That confirmed everything. So what does all this mean? All this mumbo jumbo, Rod? Please explain it to us. Well, it means chlamydia doesn't just hide inside the cell. It actively reprograms the cell to stay alive. The bacteria are manipulating the host like that toxic ex that refused to leave. And somehow convinces you, they doing you a favor. Buying you food, buying you clothes, taking you places. It's not good for you. Cut it off. Chlamydia is literally controlling when the cell dies, how long it lives, what proteins stay active, and which immune defenses get shut down. All of that from inside its little vacuole. You feel me? The researchers basically discovered that the vacuole is a survival platform and that MCL1 stabilization is essential. And that the Zulu Nation, the deubiquitination, Jesus Christ, is the key mechanism. This is the heart of the infection. So why this matters for the rest of the podcast is because now we know if you break the vacuole, the infection collapses. Get him out of there. But if you disrupt MCL1, the chlamydia cannot grow. The whole cell kills itself and the bacteria. This research opens the door to a whole new type of treatment that doesn't aim at bacteria. It aims at the vacuole, the safe house. I would say this is the foundation of the podcast and honestly the coolest part of biology. So, now we're going to get into the therapeutic angle. What the future of STI treatment could look like session. This is where the science actually turns into something real, something useful, something that can one day save people from getting long-term damage, Because once you understand how chlamydia survives inside the vacuole, the next question is, how do we break that bubble? Pop. I'm thinking about Welcome to Dairy. That's a very good, y'all should watch Welcome to Dairy. Sorry. How do we pop that trap house Airbnb that they built inside your cells and they won't leave, running it out, throwing parties and everything? And let me tell you, this is where the researchers got decided when they started figuring this out, y'all. So the vacuole is the biggest drug target. The antibiotics go after chlamydia directly, like trying to square it with a bacteria head on, right? But that'll work for now. It's kind of working. But the bacteria evolves, right? It just keeps on getting new upgrades, like a brand new iPhone, Sooner or later, regular antibiotics don't work no more. You've been taking it over and over and over and over again, right? You're building up an immunity. Here's the idea. Don't attack the bacteria. Attack the vacuole. Attack that safe house, The inclusion vacuole is the one thing chlamydia cannot live without. It's like cutting off the Wi-Fi in a college dorm. I can't live without my Wi-Fi in my college dorm. Well, I don't live in a college dorm, but that's besides the point. Remember that protein MCL1, the don't die yet signal chlamydia stabilizes? Yeah, that would be the number one target. if scientists create a drug that stops MCL1 from sitting on the vacuole, or speeds up its breakdown, or blocks the ubiquination that protects it, then the whole cell finally gets to self-destruct like it's been trying to do since the beginning of this daggone podcast, and probably since the beginning of time. Also, shout out me for being able to pronounce decubitation. Yep, baby wins. Chlamydia is basically keeping the cell alive against its will. It's giving hostage energy. You feel me? And this is like one more violent. This one is more violent, therapy strategy number 2, a little more violent, But sometimes violence is the answer. It gotta be. Sometimes you just need the results. If a drug can destabilize the vacuole membrane even a little bit, then boom, the immune system sees chlamydia, the lysosomes finally fuse with it, the bacteria explode, and it's like busting open. Strategy number 2 for therapy, popping a vacuole. This one is more violent, but hey, sometimes violence is the answer. Sometimes you need results. Sometimes you need to get your hands a little dirty. If a drug can destabilize the vacuole membrane even a little bit, then boom. The immune system sees chlamydia, lysosomes finally fuse with it. The bacteria gets wrecked. It's like busting open a locked treasure chest, and getting all the gold that's inside of it. Therapy strategy number 3, block the ubiquination. So remember how chlamydia removes ubiquitin tags from MCL1 to keep it alive? Scientists think, what if we block that? It's like taking away the bacteria's eraser. Suddenly, all those destroyed its protein tags stay on. MCL1 disappears. Where'd it go? The cell dies naturally. Chlamydia loses its home. Simple chemistry, devastating results. Therapy strategy number 4. Stop the vacuole from forming. This is the nuclear option. What if we stop the vacuole from forming in the first place? That means no safe house, no room to grow, and chlamydia dies on entry. It's like catching somebody trying to break into the house, locking the door, locking the window, locking the chimney, everything. Why is this better than just antibiotics? Well, the best part of these therapies, they don't attack the bacteria directly. They attack the structure that the bacteria needs. That means there is a way less chance of resistance, way less chance of long-term health complications, and way more targeted treatments. And honestly, this is the direction medicine is moving in anyways. Precision targeted therapies. If we don't know how the bacteria survives, we can't beat it. The vacuole is the key. It's the weak spot, the Achilles heel. The research helps us create smarter medicine. Not just treating symptoms, but targeting the root of survival. And that's how we beat STIs that keep evolving. And honestly, it's just pretty cool biology. Like, the tiny bacteria is hacking your proteins, editing your cell signals, building a bunker, avoiding every alarm system, and throwing a cell-size party. And you don't even know. Science is crazy, and that's why we study cell biology. So, we have made it to the end. Made it to the end. Let me bring y'all back home, bring everything back home. Chlamydia is way more than an STI people joke about. Inside your body, it's out here building vacuole survival systems, biochemical hacks, and escape routes. It's basically the Navy SEAL or bacteria. But you know the science behind it. You understand the life cycle, the vacuole, the MCL1 hijacking, the immune evasion, and how future drugs might shut it all down. The research matters. The science matters. You understanding this matter. You matter too. And if Red Bull wants to sponsor a biology podcast, tell them to hit my line. All right, y'all. This is Rod signing out. Go study. Go get tested. Take care of yourselves.